How do fish breathe underwater? Fish are remarkable creatures that have evolved to thrive in aquatic environments. One of their most fascinating adaptations is their ability to breathe underwater, a feat that has intrigued scientists and nature lovers alike. Unlike mammals, fish do not have lungs, so they cannot breathe air directly. Instead, they rely on specialized structures called gills to extract oxygen from water. In this video, we will explore in detail how fish breathe underwater, the science behind their gills, and the adaptations that make them perfectly suited for life beneath the surface. Let's dive in. Before understanding how fish breathe, we need to appreciate the key challenge of living underwater: oxygen availability. Water contains far less oxygen than air, with only about 1% of water being oxygen compared to 21% in air. This means fish need highly efficient systems to extract the little oxygen available in their environment. Unlike humans, who use lungs to inhale air and extract oxygen, fish use gills to extract dissolved oxygen from water. This adaptation allows them to survive in a variety of aquatic habitats, from freshwater lakes and rivers to the depths of the ocean. What are gills? Gills are the respiratory organs of fish, specially designed to extract oxygen from water and remove carbon dioxide from their blood. Fish gills are located on either side of their head and are protected by a bony plate called the operculum. The gills consist of the following key parts: gill arches. These are bony or cartilaginous structures that provide support for the gills. Gill filaments, long, thin structures extending from the gill arches. These filaments are where oxygen exchange occurs. Lamellae are rich in blood vessels and increase the surface area for gas exchange. The structure of gills maximizes efficiency by providing a large surface area for oxygen to diffuse into the bloodstream and carbon dioxide to diffuse out. The process of breathing in fish breathe through a process called buccal pumping, which involves the coordinated movement of their mouth and gill covers to create a flow of water over the gills. Here is how it works step by step. Water intake. Fish open their mouths to let water flow inside. Water movement. As the fish closes its mouth, water is pushed over the gill arches and filaments. Gas exchange. Oxygen dissolved in water diffuses across the thin walls of the lamellae into the fish's bloodstream. At the same time, carbon dioxide in the blood diffuses out into the water. Water exit. The water, now depleted of oxygen, exits the fish through the operculum. This process ensures that a continuous flow of water moves over the gills, providing the fish with the oxygen it needs to survive. The science behind gas exchange. Gas exchange in fish relies on the principle of diffusion, which is the movement of molecules from an area of high concentration to an area of low concentration. Water flowing over the gills has a higher concentration of oxygen compared to the blood in the fish's gill capillaries. Oxygen naturally diffuses into the blood, where it binds to hemoglobin, the oxygen-carrying molecule in red blood cells. Simultaneously, carbon dioxide, a waste product of cellular respiration, diffuses out of the blood into the surrounding water. Countercurrent exchange system. Fish use a highly efficient system called countercurrent exchange to maximize oxygen absorption. Here's how it works. Blood in the gill capillaries flows in the opposite direction to the flow of water over the gills. This countercurrent flow ensures that oxygen continuously diffuses from the water into the blood along the entire length of the lamellae. By maintaining this gradient, fish can extract up to 80% of the available oxygen in the water, a far higher efficiency than lungs in terrestrial animals. Adaptations for different environments. Fish in freshwater and saltwater face different challenges when it comes to respiration. Freshwater fish. These fish live in oxygen-rich water, but must regulate their internal salt balance. Saltwater fish. They live in oxygen-poor environments, but are adapted to conserve water and eliminate excess salt. Some fish species have adapted to survive in environments with very little oxygen, such as muddy ponds or stagnant water. Adaptations include increased gill surface area, breathing through skin and air breathing. Increased gill surface area, to maximize oxygen absorption. Breathing through skin. Some fish, like eels, can absorb oxygen through their skin. Air breathing. Fish, like the lungfish, have evolved lungs to breathe air when water oxygen levels are too low. Unique respiratory adaptations. Fish have evolved incredible adaptations to breathe efficiently underwater. Here are a few unique examples. Ram ventilation. Some fish, like sharks and tuna, use ram ventilation, where they swim with their mouths open to force water over their gills. This method allows them to breathe without active pumping movements. Certain fish, such as the betta fish and lungfish, can breathe air directly. These fish have specialized organs like lungs or labyrinth organs that allow them to extract oxygen from the air. Fish that survive in hypoxic conditions. Fish like catfish and goldfish can survive in low oxygen environments by slowing their metabolism and using anaerobic respiration. Why can't humans breathe underwater? Humans cannot breathe underwater because our lungs are not designed to extract oxygen from water. Unlike fish, we do not have gills, and water is much denser than air, making it difficult for oxygen to diffuse efficiently into our bloodstream. For humans to survive underwater, we need external devices like scuba tanks, which provide a supply of breathable air. Fun facts about fish breathing. Fish gills can extract up to 80% of the oxygen from water, whereas human lungs extract only about 25% of oxygen from air. Sharks must keep swimming to breathe because they rely on ram ventilation. Some fish, like the mangrove killifish, can survive for days out of water by breathing through their skin. Fish are extraordinary creatures that have evolved efficient and specialized systems to extract oxygen from water. Through their gills, countercurrent exchange systems, and other adaptations, fish can survive and thrive in environments where oxygen is limited. From freshwater streams to the deep ocean, these incredible respiratory mechanisms demonstrate nature's ingenuity. What do you think about the fascinating way fish breathe underwater? Have you ever wondered how other aquatic animals manage to survive? Share your thoughts in the comments below. And don't forget to like the video and subscribe to the channel for more amazing topics about the wonders of the natural world.